Good morning, evening, afternoon, whatever time you might be watching this class. Today we are going to do chapter 2.3, Systems of Linear Equations into Variables. Now, we're going to solve systems graphically by substitution and by elimination. Now, a system of linear equations is a collection of linear equations containing the same set of variables. So if we look at solution by substitution, what is going to happen is one equation is going to be solved for a variable, and that variable is going to be replaced by the equivalent expression in the other equation. So the very first example we have here for substitution is set up pretty nicely. It's p equals 200 minus 2q, and p equals 60 plus 5q. So what essentially we're going to do is we're going to take this first equation here, where p equals 200 minus 2q, we're going to substitute this part in here for this p right here. So essentially what we get is 200 minus 2q equals 60 plus 5q. Okay, now we can solve for q. So I'm going to add 2q to both sides, and I'm going to get 200 equals 60 plus 7q, and then I'm going to subtract 60, and I'm going to get 140 equals 7q, so that q equals 20. Okay, we're not done yet. We still need to solve for p. Okay, so now what we're going to do is we're going to plug 20 into either equation to find p. It doesn't matter which one, you'll get the same p either way. So if I plug it into the first equation, p equals 200 minus 2 times 20, so p equals 200 minus 40, which is 160. So our p here is going to be 160. Like I said, it would have worked if you plugged it in the other equation too. Would have worked out just fine as well. So p equals 60 plus 5 times 20. 5 times 20 is 100. 100 plus 60 is 160. So you get 160 either way. So it doesn't matter which one you plug it into. You don't have to plug it into both. Just pick one. Alright. So we've got a system here for solving systems of equations by substitution. Step 1, we're going to solve one of the equations for one of the variables in terms of the other variable. The very first example we did, it was already solved out for us. And number 2, we're going to substitute the expression from step 1 into the other equation to give an equation in one variable. Step 3, we're going to solve the linear equation for the variable. Step 4, we're going to substitute this solution into the equation from step 1 or into one of the original equations and solve this equation for the second variable. And number 5, we're going to check the solution in both original equations or check it graphically. Okay, so got a system here that we're going to solve using substitution. First thing we've got to do is we have to solve one of these two equations for one of the variables, either x or y. I'm going to start with the first one here, and I'm going to solve it for y. Let's solve the first equation for y. So we get 4y equals negative 3x plus 10. I just brought the 3x to the other side by subtraction. I'm going to divide by 4 here to get y by itself. And I get y equals negative 3x over 4 plus, we need to reduce this 10 over 4. 10 over 4 reduces to 5 over 2. Okay, now what I'm going to do is I am going to take this, what y is equal to, we found y to equal to, and I'm going to input it for this y right here. Okay, so I'm going to go 4x minus 2 times that whole y right there, which is 3x over 4 plus 5 over 2 equals 6. Now I have to work on my simplification here. So I'm going to leave the 4x alone for now. I'm going to distribute this 2 to both of these terms. Negative 2 times negative 3 is a positive 6. So I get a positive 6x over 4. Negative 2 times 5 over 2 is going to give me a negative 5. And that equals 6. Now I can simplify this term here a little bit. And I can get 4x plus 3x over 2 minus 5 equals 6. I'm going to add 5 to both sides. Here gives me a 4x plus 3x over 2 equals 11. Now I need to combine these x terms here. In order to do that, I need to convert and use a common denominator. Common denominator here is going to be a 2. 4x, when put over a 2, needs to be an 8x. Now I can add the two terms because they have a common denominator. 8 plus 3 is 11. So I get 11x over 2 equals 11. So if I multiply by the reciprocal here, the reciprocal here is 2 over 11. That cancels this out and that out, and I'm just left with an x. And the 11 and the 11 cancel out. I'm just left with a 2. So we've solved for the x value here. Now I need to take this and plug it back into one of these two original equations and solve for the y value. So I'm just going to plug it into the first one. 3 times 2 plus 4y equals 10. 3 times 2 is 6, plus 4y equals 10. Maybe you can see now that y has to be 1, but if not, you can subtract 6 from both sides. We get 4y equals 4, divide by 4. We can see y equals 1. And we're done. We have solved the system of equation by substitution. Okay? Let's look at the next problem that we have here. And change the color back to blue. Okay, so the next system of equations we have is y equals 0.158x minus 0.0949, and y equals 0.037x plus 1.477. Okay, the good thing here is it's already solved out for y, so essentially all we got to do is substitute this first one in for y down here, essentially setting them equal to each other. Okay. Alright, so that's what we will do. We will do 0.158x minus 0.0949 equals 0.037x plus 1.477. Alright, so I'm going to get my x's together to start out with. I'm going to subtract 0.037x on both sides. And I'm going to get, you can do this by hand if you want to. This is actually pretty simple by hand. But you don't have to. You should get 0.121x minus 0.0949 equals 1.477. Of course, we got to add the 0.0949 over. And if we add that, we get 1.477 plus 0.0949. We get the following. 0.121x equals 1.5719. Now we have to divide by 0.121. And we get that x equals 12.99. Okay. Now we still need to solve for y. Okay. So what we're going to need to do now is we're going to need to take this x value we have here, and we're going to need to substitute this x value in. Doesn't matter which equation we use. I'm going to use the second one. Y equals 0.037 times 12.99 plus 1.477. I'm going to plug that whole thing in my calculator really quick. 7 times 12.99 plus 1.477. And I get 1.9 957, excuse me, 957. 6, 3. That's what I got. Okay, so we're good to go here. Found our x and our y values by substitution. Now the next method we're going to talk about is elimination. So solution by elimination are 5 steps here. First one says, if necessary, multiply one or both equations by a non-zero number that will make the coefficients of one of the variables in the equations equal, perhaps, except perhaps for sign. Add or subtract the equations to eliminate one of the variables. Solve for the variable in the resulting equation. Substitute the solution from step 3 into one of the original equations and solve for the second variable. Check the solutions in the remaining original equation or check graphically. Okay. So, what we're going to want to do here is we want to look at the two equations we have. And we want to see what we can cancel out and what we need to do to get something to cancel out if something doesn't cancel automatically. Now what I'm seeing here is that I have a 3x and a 4x. So if I want something to cancel out here, it's not going to be that easy. I can't multiply anything times 3 to make it equal 4 or anything times 4 to make it equal 3, especially not a whole number. I mean, I could use fractions and stuff, but we don't want to get that complicated. But if I look at my y variable here, I've got a 4y here and a negative 2y here. I could easily multiply 2y times 2 and be able to cancel out this 4y with a negative 4y. Follow what I'm saying here? So if I multiply this whole bottom equation here by 2, the resulting equation that would give would be 8x minus 4y equals 12. Now if I keep that original equation I had up top, 3x plus 4y equals 10, and I set it up as an addition here, then 8x plus 3x is 11x. 4y plus a negative 4y cancels out to be a 0. And then 10 plus 12 is 22. So that whole y term just canceled out. All I'm really left with here is 11x equals 22. And I can easily solve for x here by just dividing by 11. And that gives me an x equals 2. And now that I know x equals 2, I can plug that 2 back into any of these original equations and find out what my y equals. So 3 times 2 plus 4y equals 10. 3 times 2 is 6. So I get 6 plus 4y equals 10. I subtract 6. I get 4y equals 4. Divide by 4. And y equals 1. And it's that simple. That's simple, guys. Alright. Now if we look at this one has decimals and some really big numbers on top of that. I get x plus y equals 300,000, and I get 0.12x plus 0.07y equals 27,000. Now I purposely lined this up. There's nothing missing in front of these x's and y's here. I purposely lined it up so the x's and y's would line up so that we could do an easy elimination. Now with this one, I could cancel out either the x or the y. Okay, I'm going to cancel out the x in this one, and in order to do that, I'm going to multiply this entire equation up here times 0.12. And what that'll render is 0.12x plus 0.12y equals, and then you'll have to multiply 300,000 times 0.12. So 0.12 times 300,000, that gives you 36,000. Now I'm going to rewrite this bottom equation so it lines up nice. Now with this, if I add these, nothing's going to cancel out. So what I'm going to want to do here is subtract this bottom equation. Okay, you can you can get around this if you want to by multiplying this top equation by a negative 0.12. And if you do that and carry that all the way through, then you can add the two equations. But if you don't do it, you can just subtract the equations like we're doing here. Now, 0.12x minus 0.12x is a 0. 0.12y minus 0.07y should give us a 0.05y. Okay. And then 36,000 minus 27,000 should give us 9,000. You have to carry that minus all the way through when we do this, okay? So it has to go to each and every one of these terms. If you don't do that, then you're going to make an error, okay? So now if I want to get y by itself, all I have to do is divide by 0.05 on both sides, so that y equals 9,000 divided by 0.05, which is 180,000. So I've solved for my y here. Yes, that was a terrible circle. Let's try that again. Now we want to come over here and solve for our x. And you can plug it in either of them if you want to. I'm going to plug it in the first one because that's the most simple one. So x plus 180,000 equals 300,000. So obviously just got to subtract 180,000 on both sides. And that leaves me with an x value of, I believe, 120,000. And we're good to go. Solved it by elimination. Something that looks a little complicated turned out pretty easy, to be honest. Now, a lot of times you'll be able to solve the system of equations by any means that you really seem to find necessary, okay? So what we have here is a setup that looks like x plus y equals 20 and 0.12x plus 0.08y equals 1.8. And you can solve it by any means necessary. I personally like elimination, so I'm going to use elimination here. Okay, so what I'm going to do is I'm going to do something a little different than what we did the last setup here. I'm going to multiply everything by negative 0.12. You can multiply it by positive 0.12 and then subtract it if you want to. I'm just going to go ahead and show you how you can do it this other way and multiply by a negative straight out. So if I do that, I get negative 0.12x minus 0.12y equals, let's see, what is 20 times 0.12? 2.4, negative 2.4. And I'll rewrite this bottom equation here, 0.12x plus 0.08y equals 1.8. I'm going to add them because I can add these two terms here and they're going to cancel, which they do very nicely. That leaves me with a negative 0.04y. And let's see, negative 2.4 plus 1.8 should give me a negative 0.6. So that if I divide by this negative 0.04, I get You get 15, guys. 15 for my y. Alright, so if my y is 15, I'm going to plug it back into that first equation. X plus 15 equals 20. I think you can see here that x has to be 5. And I've solved that a system of equations with elimination. Now, if you would rather do substitution there, by all means, be my guest. Uh-oh, having another system meltdown here. By all means, be my guest and use substitution. If you prefer that method, that's perfectly fine. Now, this one says solve the following system by elimination. Oh, Lord. Now, why, Mr. Shikes, would you set it up as a substitution and then make us solve it by elimination? Because I want to show you something. Okay. In order to solve this system by elimination, if the y is on the left-hand side on this side, the y has to be on the left-hand side on your other equation. If it's not, you need to get it there. I can't cancel stuff across this equal sign. So what I'll need to do if I really want to solve this by elimination is I will need to subtract this 3y over here so that I can set it up to where my equal signs line up. And I have an easy cancel here. I can't cancel across the equal sign. So I can't cancel this 2y. Even if this was 2y here or a negative 2y here, I couldn't cancel them because they aren't on the same side of the equal sign. You have to have them all on the same side of the equal sign here to cancel them. So in order to cancel here, what I'm going to do is I am going to multiply this equation by negative 6. That way my x's cancel here, and I'm ready to go on it. I can just add it. So I'm going to leave this first equation alone. I'm going to multiply the second equation times negative 6. So I get negative 6x plus 18y equals negative 12. I'm going to add these two equations together. I get a 0 here. I get a 20y here. And I get a negative 10 here. So that if I solve for y, just divide by 20. And I get y equals negative 1/2. Okay? If y equals negative 1/2, then I have x equals 3 times negative 1/2 plus 2. That gives me x equals negative 3 over 2 plus 2. I have to rewrite that 2 with that common denominator of 2. So I'll rewrite it as 4 over 2. And I notice that that gives me a half. 3 over 2, or negative 3 over 2 plus 4 over 2 gives me a positive 1/2. So my x here is simply 1/2. And we're done. We have solved that system by elimination. Now, in that case there, if I was given the option of elimination or substitution, I probably would have chosen substitution. Mainly because it was already set up pretty nicely to substitute that x into the other side. Now, you do have a third option of solving systems of equations. That's a graphical method. And I'm sure I'll have several of you choose the graphical method of doing things, which is perfectly fine. In order to do it the graphical method, what we're going to do, you've got two methods that'll work. Method number one is you let your y1 be 3000x minus 7200. And you let your y2 be 5800x minus 8600. So your original, of course, I don't know if I said this, but your original equation is right here. 3000x minus 7200 equals 5800x minus 8600. So we're going to let y1 be this side. We're going to let y2 be this side. And now what we're going to do is we're going to plug in both y1 and y2 in our TI calculator in the graphing section. And we're going to find the point at which they intersect. Okay, the x value, just the x value is all we care about. The x value for this point of intersection will be the answer to the equation above. Okay, so what I'm going to do is I'm going to pull the calculator up, and I am going to show you how to do this with method 1. Before I do that, we're going to talk through method 2. That way we can kind of do both of them at the same time while we're over there at the calculator. We won't have too much flashing back and forth. Now with method 2, what we do here is we take this formula we've got, and we get everything to one side. Okay, so if I bring everything to the right hand side, I subtract 3000x. That gives me 2800x minus 8600 equals negative 7200. I add the 7200. What you'll notice is that gives you 0 equals 2800x minus 1400. Now, to be perfectly honest with you, if you get your systems of equations this far, you might as well have just finished it out and solved it by hand. But if you're particularly inclined to, what you can do is set that equal to 0, which is what we did. We can change that 0 to your y. So we'll basically put this in our y1 right here, and then find the 0 with the TI-84 calculator. So we'll go through that method 2 on the calculator when we jump over to it as well, but we will do method 1 first. So meet me over at the calculator, get yours ready, and I'll see you there in just a second. Alright, so we're over here at the calculator. We're going to do method 1 first. I'm going to go to y equals. If you have anything in here you might want to clear it out, probably a good idea. I'm going to type in our first equation, which was y1 equals 3000x minus 7200. And our y2 we would set equal to the other side of the equal sign, which was 5800x minus 8600. Okay. Now that we've done that, what we will do is I'm just going to zoom standard on it, see how it does. It may do a good job. It does a terrible job. So we're going to do zoom fit, which is zoom 0. You can scroll down to it, or you can just hit 0. And when we zoom fit, it turns out pretty nice. We can see where they intersect at. Their point of intersection is what we want to know here. So if I hit second calc, scroll down to intersect, it's going to ask me first curve, second curve, guess. It's all pretty close. We get an answer of x equals 0.5 and y equals negative 5,700. Okay, so that would be our answer there. This is only really an equation set up for x, so the only value we really care about for this equation is our x, so x equals a half. Now if we would have set it up the way we did in method 2, in method 2 we solved it down to we really only have one equation equal to 0, to where we had 2800x minus 1400. If I graph this one, all I have to do is do second calc 0, and it'll ask me to go left bound, right bound, and then guess. And that 0 that we get will be the answer if you use method 2. My honest preference here is method 1, because it's less solving that you have to do. It's straight entry to your calculator, but either method works. You get the same thing. X is a half, or 0.5. So like we found on the calculator, with either method we found x equals 0.5, or if you'd rather write it as a fraction, x equals a half. Very easy. Now we have another example here with y's and x's. Okay, it's set up as y equals 0.15x minus 0.0949 and at y equals 0.037x plus 1.477. Should look familiar. We solved it earlier. Now we're going to solve it graphically. So we're going to let the first one be our y1. We're going to let the second one be our y2. And we're going to use method 1. I'm not going to go into solving and using method 2 here. Method 1 is a whole lot less work, and that's what we're going to do. So meet me back over at the calculator, get yours ready. I'll see you there in just a second. Alright, so we're over here at the calculator. I went ahead and went to y equals. Cleared out my old stuff and my y equals from that last problem. I'm typing this new problem, 0.158x minus 0.0949, and in y2 we said we were going to type in 0.037x plus 1.477. Alright, so we got our y1 and our y2 typed in. You can hit graph, see if it shows up. That is a terrible job of graphing in my opinion. I'm going to try zoom standard, which is number 6. It doesn't show their point of intersection, which is no good. That's what we need to see. I'm going to try zoom fit. Zoom fit did an even worse job. I'll tell you what I'll do here. When I come up to something like this, I'll just zoom out. I can tell they intersect somewhere up here on the right hand side, so I'll move my cursor close to where I think they intersect, kind of off screen, and I'll hit enter, and what it'll do is it'll recenter it kind of around that area and zoom out a little bit. Now I can see where they intersect at. Hopefully that helps you kind of get your screen set up correct as well. Now I will do second calc intersect, and it'll say this curve, that curve, guess. I'm going to guess it's somewhere around right here. And it will say your intersection point is 12.990909 and your y point is 1.9576636. So that's your answers. That's your x value and your y value for this problem. You can verify this by scrolling up or going back in your lecture notes and looking at I think it's the second substitution problem we did. It was the same problem. We solved it with a whole lot of handwork for substitution, and we got the exact same answer. Our calculator did it like that. So calculator can knock it right on out, especially when it's already solved for your y's. Made it really, really simple. Alright, so we got our answer for that one. Do I really need to write it? I hope not. If I need to, it was 12.99 for your x. Like I said, go up and check that substitution problem as well. Our y here was 1.9576, maybe something like that. We had approximated. So we're good to go there. Okay, like I said, check it with the substitution problem. See how much time we save by just using the calculator and letting it do the brunt of the work. Alright, next example. Each ounce of a substance A supplies 6% of a nutrient a patient needs. Each ounce of substance B supplies 10% of the required nutrient. If the total number of ounces given to the patient was 14 and 100% of the nutrient was supplied, how many ounces of each substance was given? Okay, so we have to write a set of equations here from this word problem, and then after writing the set of equations, we're going to have to actually compute what A and B should be. Now, what I'm going to do is I'm going to write the easy part first. The total number of ounces given to the patient was 14. That means the number of ounces of A plus the number of ounces of B had to add up to be 14. Okay. Now, each substance of A supplies 6%. So if I look at, you can do this one of two ways, but I'm going to look at it this way. I'm going to say, okay, A provides 6%, 0.06. B provides 10%, 0.1, or 10 if you prefer for the 10%, and that adds up to be 100% or 1 of the nutrient supplied. Okay, so now we have a system of equations. Pretty simple. Now you could have, just being the devil's advocate here, if you would have written it this way as well, A times 6 plus B times 10 equals 100, that would have worked as well instead of using that second equation. I like to write my percents as decimals. I mainly do it because I'm also the statistics teacher at the university, and when we do our math and statistics, we convert our percents to decimals. So I try to stay consistent with what I teach throughout all courses. But the other one, it would slip you through. It would get you the answers that you need as well in this scenario. Now let's solve for our A and our B. I'm going to use elimination. So I guess I could have left it as an orange here. So I'm going to multiply this entire thing by negative 0.06. And what that's going to give me here is negative A times 0.06 minus B times 0.06 equals, I have to come over here and multiply 14 times 0.06 as well, and it will be negative, so 14 times 0.06 gives me negative 0.84, so that if I add these together, there's a dot right there, if I add these together, that first one cancels out. This one leaves me with 0.04b, and 1 minus 0.84 will leave me with 0.16. If I divide by 0.04, 0.16 divided by 0.04 gives me a B value of 4. Now, if B is 4 and A and B have to add together to be 14, I hope you see that A is 10. And we're good to go. So he needs he needs 10 ounces of substance A and 4 ounces of substance B to get his 100% of the nutrients supplied. And we have solved this word problem. Now, something to be aware of are systems with non-unique solutions, which happens sometimes. So we want to look at kind of how those look and how those set up. Okay, so we've got our systems of equations here. I am going to solve it by elimination. And to do that, what I'm going to do here is I'm going to multiply this top equation by 3. If I do that, I get 6x minus 9y equals 12. And I'm going to rewrite this bottom equation, which is 6x minus 9y equals 12. And what you notice here is we have a vast similarity going on here. So if I subtract this bottom equation from this top equation, I get a 0 plus 0 equals 0. And I wind up with 0 equals 0, which is a true statement. 0 always equals 0. So if I wind up with a true statement here, what I have here is infinitely many possible solutions. So if you wind up with a true statement at the end with no variables, like 0 equals 0, or 1 equals 1, or 5 equals 5, then you have a situation where you have infinitely many solutions. Okay. Now, if I look at this one, what I'm going to do here, still going to multiply everything by 3. So I get 6x minus 9y equals 12. And that'll be over 6x minus 9y equals 36. So if I subtract the second one here, I get a 0 here, I get a 0 here. 12 minus 36 gives me a negative 4. Negative 24, excuse me. So I wind up in a situation where 0 equals negative 24. Now, if you think about it, does 0 ever equal negative 24? No. We have a big red flag here. 0 never equals 24, especially not in this class. So we wind up with a situation where we have a false statement, right? And since we have this false statement here, a statement that cannot be true, we have no solution. Okay, big red flag. All right, let's move on to the next one. Oops. So we got a little page here of practice problems. We're going to run through them. It doesn't tell you how to solve these. You can solve them any way you like. This one's obviously set up for substitution. It's 4x plus 6y equals 4, where x equals 4y plus 8. So I am going to use substitution. I'm going to substitute this part in here for this x. So 4 times 4y plus 8 plus 6y equals 4. 4 times 4 is 16. 4 times 8 is 32. Alright, wrote out the rest of the equation there. 16y and 6y should give you 22y plus 32 equals 4. You subtract 32 from both sides, you get 22y equals negative 28. Right? That we've done everything correct so far. I believe so. And you divide by 22 here. And you get that y equals negative 28 over 22. Yes, we want to reduce. We divide both of those by 2. We get negative 14 over 11. That is what our y is. We know our y. We can solve for our x. X equals 4 times negative 14 over 11 plus 8. Let's see here. 14 times 4 should give us 56 over 11. It's negative plus 8. And if I use my calculator to add that, you can do negative 56 divided by 11 plus 8. If you hit enter, it gives you a weird looking decimal. But if you hit your math button on your calculator, the first thing it brings you to is something called frac, F-R-A-C. if you hit enter on it and then hit enter again, what it'll do for you is it'll find the fractionalized answer for you, and it turns out to be 32 over 11. See if you can figure that out on your calculator. You'll appreciate it later if you can. Alright, so we've got x equals 32 over 11 and y equals negative 14 over 11. We're good to go on that practice problem. Okay, so on to the next practice problem. Number 2. Alright. I'm going to change colors for number 2 to a green. This one, I'm going to try to solve it using elimination. I notice if I multiply the top one by negative 3, then this part of this x will cancel out. Okay, oof, didn't mean to put the parentheses around the whole thing. It's really only around the top one. There we go, that's better. So I get negative 6x plus 15y equals, let's see, 16 times negative 3 gives you negative 48. Now I've got 6x here minus 8y equals 34. I can add this up. I get a 0 here. 15 minus 8 gives us 7. So I've got 7y. Now 48, 34 here gives us a negative 14. So I divide by 7, and I see that y is negative 2. Now I can go to either of these equations and plug this y in. I'm going to use, let's use the second one. 6x minus 8 times negative 2 equals 34. 8 times negative 2 is 16. So I get 6x plus 16 equals 34. Subtract 16. And I get 6x equals, let's see, what's 34 minus 16? That's 18. So I divide by 6. I get that x equals 3. So I have my solution set for this one. Alright, very last one of this lecture. I've got 4x minus 3y equals 9 and 8x minus 6y equals 16. Change the color of my pencil again. I'm going to multiply this top one by 2. So I'm going to get 8x minus 6y equals 18, and that's going to be over 8x minus 6y equals 16. I'm going to subtract this bottom equation from the top one. I get 0 plus 0 equals 2. Does 0 ever equal 2? No. So we have no solution. Alright. If you have any questions at all that have arisen from this lecture, please let me know. Please go and try the Chapter 2.3 homework on my math lab. If you have any questions at all with that homework, please let me know. Don't hesitate to reach out to me by email. I will see y'all next class at Chapter 2.4.